Welcome back to my YouTube channel. Today we will discuss a TIFR exam question. Question is given that every linear transformation T from R3 to R3 satisfy the condition TQ minus T square minus T plus I equal to 0. Okay. Then the transformation T is invertible or not and diagonalizable or not. This is a question. Okay. Now solution. Here given that TQ minus T square minus T plus identity equal to 0. Okay, so annihilating polynomial of T, that is ATX equal to x cube minus x square minus x plus 1. Okay, and we know that minimal polynomial belongs to the annihilating polynomial, so eigenvalues also root of the annihilating polynomial. So if 0 is an eigenvalue of T, then 0 is also root of AX. Okay, also root of the annihilating polynomials. So now check AT0, that is equal to 1, not equal to 0. So 0 is not an eigenvalue of T. Okay, and we know that if T is invertible if and only if 0 is an eigenvalue. So if we know that T is singular or not invertible if and only if 0 is an eigenvalue and 0 is not an eigenvalue, so this implies T is invertible. Okay, so this implies T is invertible. Okay, so T is invertible. Now check T is diagonalizable or not. So now find the root of the annihilating polynomial first of all. Okay, so here given annihilating polynomial ATX, that is equal to x cube minus x square minus x plus 1. Okay, so here we put 1, then 1 minus 1 minus 1 1, that is 1 is a root. So 1 minus 1 minus 1 minus 1. Okay, so this is equal to, this implies this is x square, so x cube minus x square. Okay, so here we put minus 1. Okay, and here plus 0. Okay, so this implies x minus 1 common, so x square minus 1 equal to 0. So this implies x minus 1, here we expand, so x minus 1 and x plus 1 equal to 0. So this implies x minus 1 whole square into x plus 1 equal to 0. Okay, all root belongs to the field. Okay, so eigenvalues are minus 1 and 1. Okay, here. So we choose the matrix whose minimal polynomial is this equal to annihilating polynomial. Okay, so we choose the matrix with the minimal polynomial of this matrix, suppose A, matrix A. Okay, so minimal polynomial of the matrix is x minus 1 square into x plus 1. Okay, so then we conclude this matrix is not diagonalizable but invertible, also invertible and following the condition. If we choose this, Okay, and we know that a matrix is diagonalizable if and only if the minimal polynomial is distinct linear factor, if and only case. Okay, here is we choose the minimal polynomial ax equal to mx equal to x minus 1 whole square and x plus 1, then this is a not distinct linear factor. Okay, here repeated root here. Okay, so this implies this matrix is not diagonalizable, and we know that every monic polynomial we have a corresponding a matrix. Okay, and this matrix is called companion matrix. Okay, we know that result, and we know that if monic polynomial x to the power n plus a n minus 1 x to the power n plus dot 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 plus a1 plus a naught. Okay, so the corresponding matrix is given as follows: a equal to, that is minus a naught minus a1 dot 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 minus a n minus 1. Okay, and 0 here, 0 0 all here. Okay, and 1 here. Okay, 0 0, this is 0 1 0 0, that. Okay, and here 0, and last here 1 and 0 dot dot. That is up lower diagonal is 1 1 1, and here put this matrix coefficient. Okay, polynomial coefficient. So we get this matrix. So we have here minimal polynomial is ax, that is equal to x cube minus x square plus 1 minus 1 plus 1. So corresponding we matrix defined a equal to as follows. So here minus 1 plus 1, okay, and here plus 1, okay, and here 0 0 1 0 0 1. Okay, this matrix we define. Okay, we choose this matrix, so this implies this matrix satisfy the characteristics polynomial. Okay, satisfy the analytic polynomial and given condition, and also invertible but not diagonalizable, because his minimal polynomial is not not distinct linear factor. Okay, so answer of the question is B. Okay, A is invertible, T is invertible but not diagonalizable, not necessarily diagonalizable. Okay.